welcome to Math Practice. In the first two videos on integration, we had studied integration by substitution method and integration using trigonometric identities. In this video, we are going to study a very important method which is integration using partial fractions. Many examples are based on integration using partial fractions, so watch the video till the end. So first of all, when this method of partial fractions is used for integration. Now first thing is, what do you mean by proper and improper rational functions? If px and qx are two polynomials, if the degree of px is less than degree of qx, means for example px is linear 3x plus 5 upon qx quadratic 2x square plus 10x plus 1, then it is a proper rational function. Otherwise it is improper. If it is improper, you can convert to a proper rational function. So basically this method is used in which the integrand, which is an improper rational function, is written as a sum of simpler rational functions. So it is called partial fraction decomposition. It will be very clear as we take the examples. Now this is the list of, you can say, formulae which you need to remember. Actually there is no need to remember also. As you go on doing the examples, it will come naturally. So we will take examples for each of the cases to understand how the partial functions are formed. Let us straight away start with the first example, which will give you an idea of what is the method of partial fraction. Now you can see, as I told you, this is a proper partial fraction in which the degree of numerator is less than the degree of denominator. Now what you do is, first step is you factor the denominator. What is the denominator? X square minus 3x plus 2. So what are the factors? X minus 2, x minus 1. This is simple. Now what you do is you decompose the fraction. Means basically what is your integrand? X plus 1 upon x minus 2 into x minus 1. So this you can write it as sum a upon x minus 2 plus sum b upon x minus 1. So now our aim is to find a and b. So now what is x plus 1? The numerator x plus 1 is on the right hand side. When you take the LCM, it is a into x minus 1 plus b into x minus 2. So you just need to simplify this. Now simple way is, anyway you can get the value of a and b. Simple way is, suppose if I take x is equal to 1, then I will get b as minus 2. And if I take x is equal to 2, I will get a as 3. Replace the values of a and b. So now what is our function which we need to integrate? It is integral of 3 upon x minus 2 minus 2 upon x minus 1. Just break it in two parts. First one is 3 into integral of 1 upon x minus 2 dx. You know 1 upon x type of functions, what is the integral? Log. So log means your ln or log with the base e. Even if you write log, it means log with the base e. I am repeating this again. So your answer is integral I is 3 ln of mod x minus 2 minus 2 ln of mod x minus 1 plus c. Example 2. Integrate the function 3x minus 1 upon x minus 1, x minus 2, x minus 3. Now here you can see the numerator is again linear 3x minus 1, but the denominator is of degree 3. As I told you previously in the list which was given to you, this is of the type in which your denominator has 3 factors. Okay. In the previous example, we needed to factorize the denominator. Here already the factors of the denominator are given. So simply you just have to write 3x minus 1 upon x minus 1, x minus 2, x minus 3 as sum a upon x minus 1 plus sum b upon x minus 2 plus sum c upon x minus 3. So now your 3x minus 1 is a into, taking the LCM on the right hand side, a into x minus 2, x minus 3 plus b into x minus 1, x minus 3 and c into x minus 1, x minus 2. Now over here again, first thing is, when I substitute x is equal to 1, then left hand side becomes 2 and on the right hand side it will be 1 minus 2 means minus 1, 1 minus 3 means minus 2. So it is 2, 2a. Other two terms will become 0 because I am substituting x is equal to 1. So what is the value of A? A is 1. Similarly, when you substitute x is equal to 2, you get B as minus 5, and when you substitute x is equal to 3, you get C as 4. Put back the values. So again the same thing, integral of 1 upon x minus 1 dx is log mod x minus 1, log or ln, where log is over here with the base e, minus 5 into log of mod of x minus 2 plus 4 into log of mod of x minus 3 plus c. Next example, find integral of 3 sin phi minus 2 into cos phi upon phi minus cos square phi minus 4 sin phi d phi. Okay, so now since over here you are having sine of angle phi, you can substitute as y so that it becomes simpler, and then again we can resubstitute in the answer. So let y is equal to sine phi, which will give you dy is equal to cos phi d phi, because derivative of sine is cos. Now what will our integral become? 3y minus 2 upon phi minus sine is y. So what will be cos square? 1 minus sine square means 1 minus y square minus 4y whole dy. So again when you simplify this, the denominator will be y square minus 4y plus 4, that is y minus 2 whole square. So now what is your integrand? 3y minus 2 upon y minus 2 whole square. So now this is of the type, from the list of formulae which we are having, it is of the type px plus q upon x minus a whole square. How do you write it as? Sum a upon x minus a plus sum b upon x minus a whole square. So this is equal to a upon y minus 2 plus b upon y minus 2 whole square. So now our 3y minus 2 is equal to, right hand side when you take the LCM, it is a into y minus 2 plus b. Now you can find the values of a and b by any of the methods. Either you can compare the coefficients of the terms. On the left hand side, coefficient of y is 3. On the right hand side, the coefficient of y is a. So a is equal to 3. Similarly, the constant term minus 2 is equal to constant term on right side, which is b minus 2a, which gives you b as 4. Or what you can do is you can substitute y is equal to 2, you will get b is equal to 4, and then you can substitute say y is equal to 1 and use b is equal to 4. So you will get a is equal to 3. So basically your a is 3 and your b is 4. So next step, we just put the values of a and b. So our integral is 3 into integral of 1 upon y minus 2 dy plus 4 into integral of 1 upon y minus 2 whole square dy. First term, it will be 3 log mod of y minus 2. Second term, it is of the type x raised to n. You know it is integral is x raised to n plus 1 upon n plus 1. So y minus 2 raised to minus 2 means y minus 2 raised to minus 2 plus 1 upon minus 2 plus 1, which is equal to minus 4 upon y minus 2. So now what we have is our final answer. You replace the value of your y. Okay. Now what is done over here is, instead of y minus 2, I have taken over here 2 minus y. So the minus sign gets outside. So it minus minus will become plus. So your final answer is I is equal to 3 log mod of sine phi minus 2. Y we have kept back as sine phi plus 4 upon 2 minus sine phi plus c. So your final answer will become, now see over here, since the function is trigonometric function sine, you know that 2 minus sine phi, the range of sine is minus 1 to 1. So 2 minus sine phi will always be positive. So in the first part of the answer, no need to write mod because it will always be positive. So you can write it as I is equal to 3 log 2 minus sine phi plus 4 upon 2 minus sine phi plus c. Now in this example, you have to integrate the function x square plus x plus 1 upon x square plus 1 x plus 2. Now this is of the type px square plus qx plus r upon x minus a linear factor into the quadratic factor. So over here your numerator is quadratic, your denominator has a linear factor and a quadratic factor. Then how is it written in the form of partial fractions? A upon x minus a plus bx plus c upon the quadratic factor. So now our example, we can write this equal to a upon the linear factor x plus 2 plus bx plus c upon the quadratic factor x square plus 1. So what do we have? X square plus x plus 1 is equal to, right hand side taking the LCM, a into x square plus 1 plus bx plus c into x plus 2. Now what you do is on the right hand side group the terms having x square, x and the constant term. Then compare the coefficients on both the sides. So when you compare the coefficients on both the sides, it will be coefficient of x square on both the sides. When you compare, you get a plus b is equal to 1. Then you get 2b plus c is equal to 1 and a plus 2c is equal to 1. 3 equations, 3 unknowns, you can simplify and get the value of the unknown. Anyway, you can do this. What I have done over here is, we can convert our b. You can say you can convert your b and a in terms of c. That is what I have done, and then put in the equation back. So first I have got the value of c as 1 upon 5. And again putting the value of c as 1 by 5. I am getting a as 3 by 5 and b as 2 by 5. So now this is simple 3 linear equations and 3 unknowns. You can get the value of a, b and c. So what do we get over here? A is equal to 3 upon 5, b is equal to 2 upon 5 and c is equal to 1 upon 5. So now I have put back my values of a, b and c. So what is my function which I need to integrate? 3 upon 5 into x plus 2 plus bx plus c means 2 upon 5x plus 1 upon 5 upon x square plus 1. Just write it in simple form. It is 3 upon 5 into x plus 2 plus 1 upon 5 outside into 2x plus 1 upon x square plus 1. Now first term 3 upon 5 outside, integral will become 1 upon x type. So it will become log mod x plus 2. Second term you are having 2x upon x square plus 1 type. Now remember, if you remember in the last video I told you a very important formula which is very useful in most of the examples. Integral of f dash of x upon fx is log mod fx. Over here if I take fx as x square plus 1, what is f dash? Its derivative, it is 2x. So this second term is of the type f dash of x upon fx. So its integral will be ln or log with the base e mod fx. So second term integral is 1 upon 5 log mod of x square plus 1. Third term, it is 1 upon x square plus a square type. This also we have seen in the last video, integral of some special functions. It is 1 upon a tan inverse x by a. So it will be 1 upon 5 tan inverse of x upon 1, which is tan inverse of x. So ultimately your answer is integral I is equal to 3 upon 5 log mod x plus 2 plus 1 upon 5 log mod x square plus 1 plus 1 upon 5 tan inverse x plus c. See, partial fraction method is very useful whenever you are having proper fractional functions. So next example is of the type you have to integrate 3x plus 5 upon x cube minus x square minus x plus 1. Now see, the denominator is x cube minus x square minus x plus 1. When you factorize this, you get it as x minus 1 into x square minus 1. Again x square minus 1 is x minus 1 into x plus 1. So it has become integral of 3x plus 5 upon x plus 1 into x minus 1 whole square. So this is of the type some linear factor x plus 1 into x minus 1 whole square type. So now if you see the list of formulae, you can write this as a upon x plus 1 plus some b upon x minus 1 plus some c upon x minus 1 whole square. Why? Because basically there are 3 factors. So a upon x plus 1, b upon x minus 1 and c upon x minus 1 whole square. Okay. So now your 3x plus 5 numerator is equal to right hand side taking the LCM a into x minus 1 whole square plus b into x minus 1 x plus 1 plus c into x plus 1. As I told you, when you solve many examples, you will clearly get an idea how to write it as the partial fraction. Now over here you can find the values of a, b and c by any of the method. Either you can compare the coefficients of x square, x and constant term, or what I have done over here is, which makes it more easy, you first substitute x is equal to 1, you get c as 4. Then you substitute x is equal to minus 1, you get a as half. And then you can substitute anything. If you substitute x is equal to 0 for simplicity and solve it, you get the value of b as minus half. So a is half, b is minus half and c is 4. So now our function becomes integral of 3x plus 5 upon x plus 1 x minus 1 whole square will become 1 upon 2 into x plus 1 minus half into x minus 1 plus 4 upon x minus 1 whole square. So I will be equal to, first term the integral will be log mod x plus 1. So log mod x plus 1 upon 2. Second term log mod of x minus 1 upon 2. Third term it is x minus 1 whole square. So it is again of the type x raised to n. Integral is x raised to n plus 1 upon n plus 1. So x minus 1 raised to minus 2 means integral is x minus 1 raised to minus 1 upon minus 1. So now what will be the answer? I is equal to half log of, now you know that log of a upon b is log a minus log b. So this first two terms you can simplify and write it as half taken outside, log of mod of x plus 1 upon x minus 1 minus 4 upon x minus 1 plus c. Next example, integrate 1 upon e raised to x minus 1. Now over here the idea is put e raised to x as t. Differentiate both the sides, so you will get e raised to x dx is equal to dt. So dx can be written as dt upon e raised to x, that is same as dt upon t. So now our integral will become 1 upon t minus 1, but dx again you have to write dt upon t. So it will become 1 upon t into t minus 1. Now this can be solved using the partial fraction method. So this is equal to a upon t plus b upon t minus 1. So your equation is 1 is equal to a into t minus 1 plus b into t. Find the values of a and b. You get a as minus 1, b as 1. So put back the values. It is integral of minus 1 upon t plus 1 upon t minus 1. So minus log mod t plus log of t minus 1. Again you know that log of a upon b is log a minus log b. So this can be written as log of mod of t minus 1 upon t. Re-put the value of t as e raised to x. So your final answer is log mod e raised to x minus 1 upon e raised to x plus c. Next example, integrate the function x square plus 1 into x square plus 2 upon x square plus 3 into x square plus 4. Now see, this is a little different type of example. In this, the degree of numerator and denominator both is 4. Means in short, it is not a proper rational function. It is an improper rational function which needs to be converted to a proper rational function, as I told you previously. So what we need to do this is, we need to convert it to a proper rational function, means the degree of numerator should be less than the degree of denominator. For this, first of all, let us simplify numerator and denominator. I have simplified the numerator, which is x raised to 4 plus 3x square plus 2, and denominator is x raised to 4 plus 7x square plus 12. Now, what we have to do is, you subtract x raised to 4 plus 3x plus 2 from x raised to 4 plus 7x square plus 12. So what do you get? 4x square plus 10. Now check it out. Our original function which we need to integrate, can we write it as 1 minus 4x square plus 10 upon x square plus 3 x square plus 4. You can recheck it. You will get the same original integral. So by doing this, what we have done is, the second term has now become a proper rational function. Numerator degree is 2, denominator degree is 4. So now it has become a proper rational function. So you can use your method of partial fraction. This should be clear. Now the second part of the example is, you need to first of all evaluate the term 4x square plus 10 upon x square plus 3 into x square plus 4. So here we use our formulae for px square plus qx plus r upon, if you are having a linear factor, good, otherwise another quadratic factor which is x square plus bx plus c. In short, for the quadratic factor you have to do bx plus c upon the quadratic factor type. So now see over here, your denominator has two quadratic factors. So for both of them you need to do this procedure. So for the first factor it is ax plus b upon x square plus 3, and for the second factor it is cx plus d upon x square plus 4. So now 4x square plus 10, that is the numerator, is equal to, taking LCM on the right hand side, ax plus b into x square plus 4 plus cx plus d into x square plus 3. So now you get the whole equation in which you are having 4 unknowns. You are having 4 unknowns a, b, c and d, and you will get 4 equations. So let us solve them. So now when you compare the coefficients on both the sides, coefficient of x cube, x square, x and constant term. On the left hand side the coefficient of x cube is 0, means first equation is a plus c is 0. Then b plus d is 4. Again on the left hand side coefficient of x is 0, so 4a plus 3c is 0 and 4b plus 3d is 10. So from equation 1 and 3 and you get very simply a and c as 0, and when you solve equation 2 and 4 you get the values of b and d. So your a and c are 0, b is minus 2, d is 6. So basically it is integral of 1 dx minus 2 upon x square plus 3 plus 6 upon x square plus 4 dx. So now write the integrals. Integral of 1 is x. Second term, here you are having 2 into integral of minus has become plus, so 2 into integral of 1 upon x square plus 3, that is of the type 1 dx upon x square plus a square. So its integral is 1 upon a tan inverse x by a. So it is x square plus root 3 whole square, that means 2 upon root 3 tan inverse of x upon root 3. Third term it is x square plus 4. This is again of the same type, dx upon x square plus a square, x square plus 2 square. So it is minus 6 is already there, minus 6 into 1 upon 2 tan inverse of x by 2. So when you write the final answer, it will become integral I is x plus 2 upon root 3 tan inverse of x upon root 3 minus 3 tan inverse of x by 2. So partial fraction is a very important method for integration. It is the third part in our 5-part series on integration. The links to other parts for the topic integration are given in the description box. Do like and share the video and subscribe to the channel.